everyone. Today we are going to learn last section. Yay! 10.3 Inference for two means for independent samples. So we learned the last time matched pair samples, right? So in that case, we have independent sample. So we know what independent samples we introduced last time, right? Okay, so 10.3 we have inference for two means independent samples. And then we have a learning objective, right? So independent samples, we have unrelated population. So from different populations. So population 1, population 2, we take the random sample from population 1, we take the random sample from the population 2. So we call they are unrelated populations. Yeah. So one outcome does not affect the other outcome. If we talk about the sample size, then the 5% from the population, that is independent, right? Okay, so we have the notation, right? So mu sub 1 population mean from the population 1. That's why we are using subscription 1, right? Sigma sub 1 population standard deviation from population 1, and sub 1 sample size from population 1, x bar sub 1, right? So sample mean from the population 1, but then it says X bar is related with the sample, right? So we are using sample number 1. S sub 1 is also related with the sample. So from the sample 1, so it's a sample standard deviation, right? So does population 2. So we have all the notation, mu sub 2, sigma sub 2, n sub 2, x sub S sub X bar sub 2, right? And S sub 2, right? Okay. Uh, we are going to learn hypothesis test and the confidence interval, like last section, right? Okay. So we have hypothesis testing. So we have distribution of difference of sample means. Okay. So we did not talk about what's the shape, center, and standard deviation last time, right? So in that case, we have center and standard deviation. So since we talk about the difference of sample mean, the mean is x of 1 minus x of 2 is the center. And standard deviation is, oh, this is we never seen before, right? So we had a sigma over square root of n, but this kind of a format, we didn't have that, right? Formula. So square root, square, not square, sigma square sub 1 and over n sub 1, right? So we calculated this one first, and then we calculated this one second. We add them, and then we take the square root, right? That's how we do. Yeah. But then if we are using decimals, they do that for you, right? Everything. We don't talk about the order of operation, right? Okay. Here, normal distribution, the shape, right? Okay, now we have a t distribution. All right, so we have that two populations are normal. Then we check the sample size, right? The original one is normal, or the n sub 1 must be greater than or equal to 30. N sub 2, n. We have to check the two condition, n. This is or. This is n, right? So we have to check one condition here, right? Or the original population is normal, right? The distribution is normal. Yeah. Okay. Now we have a t-scores. So normally we have x bar minus mu over s over square root of n, right? Yeah, but this one makes sense, right? Because we have a two sample, right? So this is a make sense with this, but this one, they have a squared, and then inside the square root. We never seen this kind of formula before, like earlier, right? So when we use a t-score, the sigma unknown, right? Then we are using s. That's how we know, right? Yeah, from the section 8.3, right? Okay, so this is t-score. All right. We knew that t-score is a little bit wider than z-score, right? But then when sample size is bigger, then it becomes normal distribution, right? So that's why we check that, the size. All right. Now, ooh, this is more harder, right? So we don't want to do that. Yeah, looking at this one, crazy. Yeah. Okay. I think this is enough to handle by hand, right? But this is not. That's too much. Okay. Degree of freedom. When we use T distribution, we have to use degree of freedom. All right, so we have hypothesis testing, difference of mean. Yeah, very similar with earlier one, right? Matched pair samples, right? Okay. What's difference? Only T scores different T score, right? That's it? Yeah. And the verify assumptions, yeah, but this one is similar, right? Yeah, and then left tail, right tail, two tail test, right? Okay, so same. And then conclusion is also same, but then stack crunch is different, right? So we were using stack T stacks paired. Why? Because the title is matched pair samples, right? That's what we had. T stacks paired, right? And then if we had data, right? If we didn't have data, we're using just one sample and then all the information we input there, right? Yeah. So there was sample size. Oh, we input the standard deviation. Yeah. Yeah. Whatever they gives us information, we input there, right? Yeah, with the one sample, not the two sample. But look, this one, in that case, we are using here independent samples, right? But then we have two sample, we are using it with this summary. If we have data, we are using data, right? Okay, input all the information they ask us, all right? Okay, now let's do this one. Let me arrange the note. All right, so let me read this one first, and then I'm gonna bring nice table here. So a random sample of 30 starting salaries for nurses in San Francisco, California has a sample mean of $83,647 with a sample standard deviation 17,969. And then another sample, we have 33, and then nurses for in Oakland, California, had average 79,632 with a standard deviation 16,719. So we want to test whether starting salary in San Francisco are significantly higher. San Francisco, right? Then starting salaries salary, right? Because I was a little bit confused with the salary. Salary, right? Okay, in Oakland, California, yeah, use significance 0.05. Yeah, all right. All right, so I brought a nice table here. Okay, so sample one starting salary in San Francisco, sample two in Oakland, right? Okay, so their export standard deviation and sample size. Okay, now step one, we need to identify the null hypothesis test and then alternative hypothesis test. Look, the null hypothesis test always like that, right? So we knew. So we have the null hypothesis test, mu sub 1 minus mu sub 2 equal to 0. And then alternative hypothesis test, how do we say that, right? Okay, look, test whether starting salaries in San Francisco are significantly higher than starting in Oakland, right? So that means mu sub 1 is higher, right? So mu sub 1 is higher than mu sub 2, right? So that is what? Right tail test. So there's a mu sub 1 minus mu sub 2. So right tail test. So that will be mu sub 1 minus mu sub 2 greater than 0, right tail test, right? Same as, okay? All right, so step 2, level of significance. So alpha is given 0.05. 0.05. All right, now step 3, verify the assumptions. Okay, so we have x sub 1, x sub 1, x bar sub 1, x bar sub 1, x bar sub 2, and s sub 1, s sub 2. And then the sample size is bigger than 30, so it's normal, right? So look, x sub 1 equal to 83,647, x sub 2 equal to 79, 632. And then maybe I can put the, yeah. Ooh, hold on one second. Yeah, forget it. Forget it. Come on. 2, just forget it. All right, S sub 1 equal to 17. 1,969 S sub 2, 16,719, right? Okay, N sub 1 equal to 30. N sub 2 is a 33, right? Greater than or equal to 30, and N sub 2 equal to 33 greater than or equal to 30. Thus, it's a normal, right? Distribution. All right. Step 4. Oh, very tedious. Okay, so we have a t-test statistic, right? But then luckily we have mu sub 1 minus mu sub 2 equal to 0 from the null hypothesis test, right? So we have just x sub 1 minus x sub 2, right? So we can just calculate that. So t-test statistics, right? So there will be x sub 1 X bar sub 1. Yeah, I kept saying that, X sub 1. X bar sub 1, 83, 647 minus 79, 632 over, okay, square root, inside the square root, S sub 1 squared, right? So 17,969 square over N sub 1, which is 30, plus S sub 2 square, which is 16,719 square over N sub 2, which is 33, right? Okay, please use it as most for this complicated calculation, right? Okay, so that will be 0.9155. Yeah. All right. So the next one is p-value. So I'm gonna show you how to find p-value. All right. All right. So I want to make a share screen. And I took a picture of information. Um, okay, so turn off here. Recording, right? Okay. Go to stack, t-stacks, and we are using two samples here with the summary, two samples with the summary, right? Okay, let me highlight. Okay, stack, t-stacks, two samples with a summary. Yeah. Okay. Let me click. Okay, we have two samples, right? So the first one, x sub 1, which is 83, 647, and standard deviation 17, 969, and size 30 for the first one. Second one, 79, 632, and sample standard deviation 16, 719, and sample size for the second and 33, right? Okay, so we are using hypothesis test, right? And then what was it? Right tail test. So that will be right tail test. Yeah. Okay, that's it. Compute. All right, so we read p-value in that case, right? So p-value, which is 0.1818. How do we determine the conclusion, right? So we compare with alpha, which is 0.05. What do you think? The p-value is greater than alpha, right? Okay, then how do we say fail to reject? Do not reject, right? So fail to reject. The null hypothesis test, right? Since there is insufficient evidence insufficient evidence to support the alternative hypothesis test, which is the San Francisco nurse income more higher than the Oakland nurse salary. Yeah, make sense? Let me writing. Okay, so that in starting salary for nurses is higher than in San Francisco. And then there's no space. Sorry. Then Oakland. Yeah. Okay. Let's go back. All right. So now we're gonna learn about confidence interval. Yeah. So we did earlier hypothesis test, right? So confidence interval. So this one verify we did earlier, right? So x bar sub 1, s sub 1, and x bar sub 2, s2, and then check the normal, right? So the sample size greater or equal to 30 for both sample size, right? And then we want to find the confidence interval for mean difference, mu sub 1 minus mu sub 2. And then the first one, calculate point estimate. Yeah. So we using X bar point estimate for mu, right? We are using p hat for point estimate for population proportion p, right? But in that case, we have a mean difference, right? So we are using two sample, right? So x sub 1 minus x sub 2. Yeah. Okay. Then we are using t distribution about t sub alpha over 2. Okay. We are going to use stack crunch for this one. And then margin of error. So t sub alpha over 2. So basically t sub alpha over 2 times standard error, right? Standard error. Yeah, that will be standard error. Okay, now lower limit, normally we have x plus minus margin of error, right? But then we are dealing with two sample mean, right? So that's why we have a mean difference here. So x sub 1 minus x sub 2 plus minus. So basically x sub 1 minus x sub 2 mean difference plus minus margin of error, right? Yeah. Okay. Now, using stack crunch, how do we do? Stack t stacks two sample with summary. If we have data with data, right? Okay, let us do this one. And then we have a tip. It's exactly the same as the last section. So if we have a positive, then the first one is greater than second one, right? And then if we have negative, then first one lower than second one. We are using just to compare the number, right? And then if we have one is negative, one is positive, then there's no evidence. Either groups, mean is larger or smaller than other, right? Okay, this is the same as earlier section. Okay, so we do same statement about the nurse, the starting salary in San Francisco, Oakland. We want to know about the confidence interval. Yeah. Okay. Let me show you how to do it. In seconds. Okay, so this is the one. All right, so we had a hypothesis test, right? So let me show you how to do it. So edit. Okay, so I don't have to retype everything. Yeah. So we had earlier hypothesis test, right? Now, ooh, yeah, we don't care about the hypothesis test. Uh, Now we want to do confidence interval, right? Okay, then I click the critical value. so that I can find the margin of error. So let me show you either way we can find margin of error, right? And then this is a critical value, which is T sub alpha over 2. Yeah. Okay, so you guys okay, right? How to find stack crunch. So this is how to do it, right? So we have a stack, T stacks, two sample. Yeah. Okay. Then we had this one earlier. That's why I just marked confidence interval. Yeah. Input all the information here. Yeah. Okay. Compute. Okay. So let's take a look. We have a difference, mu sub 1, mu sub 2. And looking at the sample difference here, right? That's the x sub 1 minus x sub 2. And then standard error, that is that formula, right? So crazy formula. Let me write down. What was the crazy formula earlier? So that is square root s sub square sub 1 plus s sub square sub 2. Yeah, it's a fraction, right? Okay, degree of freedom. Oh. Hold on one second. Let me talk to critical value first. That is a t sub alpha over 2, right? And then we have a lower limit, upper limit, right? Okay, very good. What's the degree of freedom? So that's 29. 29 plus 30, 32. So we have S, also, I cannot annotate it, huh? $61. All right, so let's take a look. We have, this is really crazy. Um, Let me talk about the degree of freedom. So we had a really crazy formula earlier, right? So I said, oh, we don't do that by hand, right? Because it's so crazy formula, right? There's a pain in the neck, right? So we have a fraction, right? Remember earlier? I'm gonna show you when we get back to the lecture note later on. So that fraction makes us a decimal here. Is it clear why degree of freedom is not whole number, right? Okay, so we have decimal there, degree of freedom. Normally we had n minus 1, right? But then we are dealing with two sample, right? So they say that in textbook say that degree of freedom equal to the smaller of n sub 1 minus 1 and n sub 2 minus 1, right? So n sub 1 we had 30 minus 1 and n sub 2 we had 33 minus 1. Then this will be 29 and this will be 32. We add them, then we get 50, 61, right? 61. So it's smaller than those numbers, so it's a 59. In that case, 59.31. Make sense? Okay, now margin of error, how do we find margin of error? So I forgot to tell you, right? So I did that in the beginning, how to find margin of error from the lower limit, upper limit, right? Lower bound, upper bound, right? And then since then, I always said, oh, look, the margin of error, the formula is T sub alpha over 2 times standard error, or G sub alpha over 2 and times the standard error, right? So that's why I always using the formula, right? Okay, so here, margin of error, we can still using the T sub alpha over 2. So there is T sub alpha over 2 times the standard error. So standard error is this one, right? Then we get answer, you calculate. So if we calculate, I have the number 870, 774. And then since we talk about the money, let's round to two decimal places, which is 55. Yeah. Okay. Then let's calculate that other way, right? So this is a little bit special, right? So we have lower limit, upper limit will be uh, x sub 1 minus x sub 2 plus minus margin of error, right? Yeah. Then we have upper limit. Then we can say that subtract x sub 1 minus x sub 2, then we get margin of error, right? Is it clear to you? Okay, then what's the x sub 1 minus x sub 2, which is a sample difference in there, 4015, right? So that will be minus 4015. Then we will get 8,774 and 55, round two decimal places. Yeah, make sense to you? That is margin of error. Okay, I hope we understand this one, or the concept in that case. Yeah, because calculation is easy because we are using the Sec10, right? But we have to understand what is going on here, right? Okay, very good. Uh, I am sharing, right? I have to go back. Oh, I need to take a screenshot. Okay. Let's go back. All right, so let's talk about the interpretation, right? Okay, so the lower limit is this one, right? And upper limit is that one. Yeah. Okay. One is negative, one is positive, then how do you do, right? So they say that if one is negative, positive, there is no evidence that either groups mean is larger or smaller than other, right? So we cannot compare them. Yeah. Okay, so that is in the case. So we cannot say that whether San Francisco is higher than the Oakland or Oakland is higher than San Francisco. Yeah. Okay, so they say that this result is consistent with the hypothesis test we conducted in example one. So what was the hypothesis test? We do fail to reject the null hypothesis test, right? Because there is insufficient evidence to support alternative hypothesis test, right? So they talk about that one. Yeah. Okay. Um, let us do the last question. So, this is example 3. This will be last question for this section. And then this one, we have data, right? So, uh, let me arrange. Okay, probably let me arrange here. And then we do quickly, yeah? Um, my recording, okay. I'm checking always recording. Okay, so we have n sub 1, n sub 2. We have this is cost $120. And then what else we have to know? Um, and then I think, yeah, level of significance is the point. This is alpha, right? Okay, how about what we have to know? Just quickly, yeah? We don't have to get through steps, yeah? It's a normal distribution because n is greater than or equal to 30, right? What else we have to do? The null hypothesis test always equal to, right? Minus mu sub 2 equal to 0. And then is it left tail, right tail, two tail, right? Look, the first one is publisher, second one is my open math. We are using it, right? And then publisher's system was lower than mean homework score using my open math. Yeah. Okay. So we talk about the mean, not the cost. Okay. Hmm. Ah, we don't have information because we have data, right? So I was looking for where's the information, right? So we have all the data. That's why they did not have information here, right? Okay, let's keep continue alternative hypothesis test. We can see that it's left tail, right? So uh, lower, so mu sub 1 is lower than mu sub 2. Then we can express as a difference. It's mu sub 1 minus mu sub 2 is less than 0, right? So left tail test. That's it, right? Okay, then let's do that first. Because I don't want to do too much right now. Yeah. So we are going to use Sec10 T-stacks to sample with the data, right? Okay. Let me show you how to do it. Uh, okay. This is the one. All right. So this is the one. Still recording, right? Okay. All right. So there is data set, right? Okay, let me copy and paste here. All right, so let's go to stack and t-stacks to sample with the data, right? Okay. Stack, t-stacks to sample with the data, right? Okay, let me click that. All right. So we input values in homework score publisher. And then sample two values in the my open math. Yeah. Okay. Hypothesis test, left tail, right? Yeah. So left tail. That's it, right? Okay. So we compute. So we have 0.0062, then alpha. What was it? Alpha. Um, 0.05, I believe. Yeah. Okay, let me double check here. Yeah. Uh, 0 point, what was it? Sorry. In the beginning, right? Oh, good thing I'm checking. It's 0.01. Yeah. All right. So alpha equal to 0.01. Whew. Okay. 0.01. Now, how do we conclude? Yeah. So 0.006. Which one? P-value is less than, right? So p-value is less than alpha, then we do reject, right? We do reject the null hypothesis test since there is sufficient evidence to support the alternative hypothesis test, which is the homework score of from the publisher is lower than the homework score from publisher publisher is lower than um, don't remember the what was it? My open math, right? Let me just make sure. My open math. Yeah. Okay. Let me. All right. Okay, so let's find the confidence interval that will be last concept. Okay, let me go to the Sec10 again. I'm gonna use the same information, right? So go to option and edit. Click the confidence interval, right? So which one is that? Right, believe this one, right? Okay. All right, so go to option and edit, and then we just click confidence interval. And was it 95? I believe so, right? Okay. All right, so critical value, click that. That will be T sub alpha over 2, right? So that we can find the margin of error by using formula, right? Okay. All right, so we have that. So we have lower limit, upper limit. And once again, we can find the margin of error, critical value T times standard error there, right? Then that's margin of error. And degree of freedom is slightly different, right? So we just add n minus 1, n sub 1 minus 1 plus n sub 2 minus 1, and then lower than that. So, but then we have a fraction because the formula was crazy fraction, right? Yeah, I told you I'm gonna show that, but I forgot to show that, right? Okay, so this is a lower limit, upper limit there. And looking at that, they're both negative, right? If there is both negative, let me see, uh, positive, then the first one is greater than second one, right? But then both negative, then first one is lower than second one, right? Okay, so we can say that since both negative, let me see. You want me to write down everything for you? Yeah, we can just using textbook, right? All right. So the first one, what was it? That's a publisher, right? So mean of a publisher, um, they talk about the percentage point. So using that lower limit, upper limit. So we are using just number 1.4 and 11.7% point lower than the homework grade using my open math. Yeah. Okay. It's good, right? Okay, then let me arrange the textbook, I mean the lecture note. Okay, so here we go. Oh, I forgot to tell you about the 95% confident, right? So, because we are using confidence interval, so I must say that we are 95% confident that mean score using the publisher's system is between 1.4 and 11.8 percentage points lower than the mean homework grade using my open math. Yeah. Okay. Thank you for watching. You did a great job. We finished chapter 10 until 10.3. Yeah. Thank you.